Hello and welcome to Reigate Maths. My name's Simon, and in this video we're going to be looking at the linear programming chapter from the first year of the Decision 1 unit for the edXL Further Maths specification. This video is focusing primarily on how to formulate a linear programming problem as opposed to solving linear programming problems, which we will look at in later videos. First off, what is a linear programming problem? Well, it is a problem made up by a series of instructions or limitations of produce and that kind of thing, which are looking to solve a problem. So let's have a look at some definitions and how to formulate these, and hopefully when we look at some examples, those words will make a little bit more sense. First off are the decision variables. So these are the amounts of each component or thing in your linear programming problem that can be varied. So for instance, if you're making flour arrangements, your decision variables might be the numbers of each type of flour. If you're cooking, it might be the amount of each ingredient, that kind of thing. The objective function is a formula for the thing you want to do. These will be in terms of the decision variables. Very typically, you're looking to maximize your profit or minimize your cost. The constraints are the descriptions of things that limit the amount of variables, and each of these constraints is going to lead to an inequality. So this might be, for instance, the amount of each, or the maximum number of each flour that you get delivered every day. That kind of thing. So you have a limit on the amount that you can use. You might also have ingredients or a recipe for a particular thing that you're making, and you might have several recipes. So the total amount of sugar that you can use for a particular series of cakes will need to be split between those recipes. That kind of thing. A feasible solution is a set of values for the decision variables which satisfy all of the constraints at the same time. You'll find that you get a lot of feasible solutions, and when we look at one of the methods for solving this equation, or this problem, we will have a feasible region which is the set of all feasible solutions. But there is only one optimal solution, and that is the feasible solution which meets the objective you're trying to do. So to formulate a linear programming problem, we need to turn the descriptive constraints into inequalities. Before we do that, though, we need to give the decision variables names. And these are typically X, Y, and Z. You need to write those descriptions down. So you will need to say the number of this type of thing is X, the number of this type of thing is Y, and so on. You then state the objective. So it might be maximize profit, but you need to state it as an equation or a formula in terms of X, Y, Z. Once you've done that, you then write all of the constraints as inequalities, and that is your formulated linear programming problem. Once you've got the set of inequalities, you can then look at a multitude of different methods to solve the linear programming problem. So we're going to start by looking at an example, a relatively simple example of how to form a linear programming problem. So in this example, we can see we've got some descriptions and some information that we need to turn into these inequalities. So first things first, let's go through and just identify the different bits. Now we need to define the decision variables, and we can see Ernesto is to plant a garden with 2 types of tree, palm trees and conifers. These are the decision variables. So we can say something along the lines of, let the number of palm trees be X and conifers be Y. Okay, we have defined the decision variables. It's clear what is X and what is Y. We now need to state the objective. And the annoying thing often with how they write these problems is that the objective is at the end. So he's to plant at least 10 but not more than 80 palms. That's one of our constraints. So these here are all our constraints because they limit the number of the decision variables that we've got. Here, maximize his profit with a description of the amount of profit we get for each of our decision variables. This is where we get our objective function from. So we're trying to maximize. So you need to say what you're trying to do. So it's usually maximize or minimize. We're going to give profit, just call it P. That is sort of standard. So we've got £2 on each palm tree. So the amount of profit he makes on palm trees is 2 times the number of palm trees he's got. We've then got plus £1 on each conifer. So it's plus the number of conifers. So this is the formula for the profit. We now need to go through and sort out our inequalities. We introduce those in our formulation of the linear programming problem by saying subject to. And this just means, here's the thing we're trying to do, and here are our restrictions. So we're going to go through each constraint. Usually they're formatted like this with space in between each one, so it's very clear the number of inequalities you're expecting. Don't always use that as a surefire rule, but it's a good rule of thumb to sort of give you a starting idea. So he's to plant at least 10, but not more than 80 palms. So the number of palm trees, which is X, has to be at least 10, but not more, so less than or equal to, because we can have 80. So at least 10, no more than 80. That's one inequality. I know it's strictly speaking 2 inequalities, but we're writing it as one. We can do the same thing with our Ys. He has to plant at least 5, but no more than 40 conifers. Now feel free, when you're doing these, like I'm doing here, to tick off the constraints as you're using them. That can be a really useful way to make sure you haven't missed any information. We've used our objective there. He cannot plant more than 100 trees in total. So the total number of trees is the number of palm trees plus the number of conifers. And he cannot plant more than 100. So the total has to be less than or equal to 100. And now we get a constraint that is very typical by introducing a resource. So the amount of water that he gets every day is 3,000 litres of water. Each palm tree needs 20 litres of water. Each conifer needs 60 litres of water. So we're saying that the amount of water he uses is 20 litres times the number of palm trees plus 60 litres times the number of conifers. He only has 3,000 litres of water available every day. So the amount of water he uses must be less than or equal to that total. Now, we can obviously simplify this, which you should do. So we get x plus 3y is less than or equal to 150. Now, if you're doing this, that's fine, but you should make sure that it's clear that these are the same constraint or the same inequality. So having something like an implies that sign or a therefore, just make sure it's clear that these are linked together. And that's it. That's the formulation of a linear programming problem. We've used every constraint, and we've defined our decision variables, we've stated our objective, and we've listed all of our constraints. What we're going to look at in subsequent videos is how to then go ahead and solve this to find not only the maximum profit, but also the number of palm trees and the number of conifers that Ernesto will need to plant in order to maximize that profit. Thank you for watching.